this part of the table is highlighted in yellow. Good. And so it gives us the first 6 members of the alkane group. First 6 members is from methane to hexane. Okay? So from methane to hexane can form the homologous series. Okay. Now this one is the expanded structure for the first 8 members of the alkane group. First 8 members. And so for the first one, methane is CH4. So carbon is the central atom with 4 hydrogens attached. And so carbon with 4 hydrogens. So this is the structure for methane. Then ethane, there are 2 carbons and 6 hydrogens. And so you observe that as you move down the series, the number of carbon atoms increases by 1, and that hydrogen increases by what? 2. That's the CH2. Good. And so you see that here carbon is 1. Over here carbon is what? 2. Hydrogens are 4 here. Here hydrogens will be what? 6. Then if you come down, carbon will be 3. Hydrogen will also be what? 8. In that manner. So these are the expanded. So as you move down the series, you observe that the size of the compound increases. From this, you see that this is bigger than that. As you move down, this is also bigger than that. So size increases as you move down, or what we call molecular size increases down the series. Very important. Now we continue with the characteristics of homologous series. We say that they have similar chemical properties. So for all the members of the alkane group, that is from methane to decay, they have the same similar chemical property. They have similar chemical properties. Good. Then they have physical properties that vary in a regular manner as the number of carbon atoms increases. You would observe that when we indicated the table involving the structures, the expanded structure, we indicated that as you move down the series, the size increases. Size of the compound increases. And so that's a physical property. It's a property we can see physically. So you observe that as you move down the series, the size increases. And that conforms with this point that they have physical properties that vary in a regular manner as the number of carbon atoms increases. For example, the alkanes, as we can see here, in terms of physical properties, methane, which is CH4, has a melting point of minus 182, boiling point of minus 164. Density is not known. Then ethane, C2A6, melting point of minus 183. So you just observe generally that as you move down the series, between ethane and propane, there's a swift or irregular pattern. But from that point down, you observe that there is decrease in melting points. There is increase in melting point. I beg your pardon, increase in melting point. Then you come to the boiling point. Okay? From methane to decaying, there is relatively an increase too. There's an increase in boiling point because sizes increases, isn't it? So while sizes increase, you also need good amount of energy to put away the particles, and that is why you expect that boiling point will also increase as you move down the series. Okay. And similarly with density too. And so the arrow we see here is telling us that as we move down the series, melting point, boiling point density will increase because size increases, because melting point, boiling point, and then density is highly proportional to size. The bigger you are, of course, so much energy will be needed to break the bonds because the compound is bigger. I believe that makes, that is quite reasonable. Good. And so the first 7 members of the straight chain alkane series, from methane to, first 7, from methane to heptane, methane, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the first 10. I think not first. Okay, first several members of the straight chain. So we'll consider the first 10 and not 7, sorry. Good. So the first 10 members. And so this is the molecular formula. This is the condensed structure condensed structure. Because if you look at this and that, there's no disparity. They are the same. Let's take the ethane, C2H6. So if you look at this, the condensed structure, if you check this is 1, 2, that's C2, isn't it? Then the hydrogens, 3 plus 3 is not 6. Good, so it's still the same. Just that the structure is written in a different form, which we call the condensed structural formula. And this is the name, and these are the boiling points. So you observe that as you move down the series, the boiling point increases. Good. We also look at the trends in boiling point of members of the homologous series. Melting point and boiling point increase with more carbon atoms. Of course, as you move down the series, melting point and boiling point will increase. Then, why? Why would that be the case? Let's find out why. Intermolecular forces will increase because size increases. So intermolecular force will increase. Then again, adding a CH2 adds more electrons. So as you add, because as you move down the series, you'll be adding the CH2 unit to the preceding member, to any member that comes, or subsequent member. And so as you add the CH2, more electrons are added. Then this increases, of course, if more electrons are added, it increases the van der Waals forces. It increases the van der Waals forces. Good, so we have the diagrammatic representation of that. And so we have methane, CH4, this is the boiling point, ethane, this is the boiling point. So as you move down the series, the boiling point in degrees Celsius will increase. And so, and this is the diagrammatic, or the graphical representation of that. Graphical, so you see that as you move down, these are the organic compounds indicated here from methane to decaying. Okay, and these are the temperatures. And so you observe that as you move from methane to decaying, temperature is increasing. Temperature is increasing relatively. Because temperature here is lower compared to temperature here as you move. So if I'm moving from methane to decaying, that's what happens. So this one is the molecular mass, relative molecular mass, and this one is the boiling point in Kelvin. Boiling point in Kelvin. So that the temperature, it will be increasing. Thank you. And so empirical molecular and structural formulas of the members of the series. And so that brings us to the end of the first session for the organic chemistry lesson. Thank you for being with us. We'll come your way with session 2 of our organic chemistry lesson. Thanks and see you then.